Hello, everyone. Welcome to Ragtime. This is a brand new series where we talk about retrieval augmented generation, or in short, RAG. Hi, Farzad. What are we talking about today?
Hey everyone, in this series, we're going to break down complex AI concepts into bite sized, developer friendly sessions. Today, we're kicking things off with the foundational question: what is RAG and why is it such a game changer?
But before we dive into the tech bits, we have special interview with Marco and Todd. They're going to talk about strategic importance of RAG in modern AI systems. So let's jump right in.
Hello, everyone, and welcome to Ragtime. My name is Todd Anglin. I'm a developer advocate here at Microsoft, and we're really excited to have you here with us today and to have a great guest with us, Marco Casalaina, Vice President in Microsoft's AI Platform Group. Marco, first, thank you for joining us today. And just to get started, why don't you let everyone here know what it is you do on AI here at Microsoft?
Well, I've done a number of things since I got to Microsoft about 3 years ago, but now I lead the AI Futures team. So my official title is AI Futurist. And basically, I work with all of the next generation of AI things first.
AI futurist. I think then we have the right person here, especially for our audience who wants to know about what is the future of AI. In fact, I think that's kind of where we want to start today. Everyone knows AI is impacting everything here as developers and the things we do. As a futurist in AI, can you tell us a little bit how is AI shaping the future? What's your perspective on how this is shaping the future?
Well, the agents are here. And as many of us know, these new classes of AI promise to do a lot more for us because up to this point, you thought of generative AI as mainly generating content or summaries or then answering questions. But now they can actually do things on your behalf. And that really changes the game.
So when you say do things on my behalf, they can go off and do it while I'm not there. Do I kind of have to do it with the agent, kind of side by side? How is that evolving?
Well, there are a couple of different types of classes of agents. One of them, indeed, as you suggested, is autonomous, a triggered agent that can be triggered, let's say, when an email comes in. So, for example, I built myself a little scheduling agent that if you ask me, hey, can you meet on Friday at 3 p.m., my agent wakes up and will schedule that on my calendar for me. There's another type of agent that you interact with, and so you work with it as it's doing something. And what's emerging right now is the new class of CUAs, computer use agents, that can literally use your computer or your phone.
Oh, well, that'll be amazing. I mean, just type in on my behalf. Will type my password, or how will that work with those agents?
Yeah, I mean, will it type your password? I don't know about that. I think you will have to authenticate, and
Okay,
hopefully
good,
that's how that will
good.
be. But in terms of filling out forms for you or doing tedious things like making travel reservations, it holds that promise for the near future.
All right, very exciting things coming now. With agents now kind of being a new topic for a lot of developers ramping up, and there's probably still a lot of our audience here is just trying to grapple with the large language model concepts in general. If I'm a developer coming into this space, what priorities should I have when I start looking at all of these things I could go learn and the things I need to start becoming proficient on? Where would you point a developer here at the start of 2025?
Well, if I'm not mistaken, this series here is called Ragtime, and I used to play Ragtime on this piano right over here. I'm a little bit out of practice, but maybe I can still crank out a little Scott Joplin, but that's not the ragtime we're talking about here. So, RAG, Retrieval Augmented Generation, is the beginning of much of this stuff. So, all of these agents and all this fancy stuff that we're doing now is still predicated on the large language models themselves, but also the fact that those large language models need to be grounded to information, need to be grounded to data to work properly. And that applies to standalone question answering systems, but it also applies now to these agents.
Okay, so whether we're talking about agents or just fundamental large language model work, RAG or retrieval augmented generation matters as a concept. And you touched on it just a little bit there, but could you go a little bit further and just help explain what is this retrieval augmented generation? How should a developer think of that?
Well, it starts with the fact that large language models by themselves have no knowledge of current events. They're trained as of a point in time and they're stuck as of that point in time. So, for
Right.
example, if you just go to the latest version of GPT-4, for example, and you say, who won the Super Bowl in 2025? It's not going to know. It can't know
Mm,
because the training data for those models stopped at like 2023 at some point.
I
So
see.
it can't know that. And yet, if you go to ChatGPT and you ask ChatGPT that same question, it totally does know. Why is it? Well, it's not because the underlying model is aware of it, but rather because ChatGPT runs a search first. And so it does this search and it finds out that the Eagles won the Super Bowl in 2025, and it feeds that to the large language model. So when the large language model gets that question, it doesn't just see that question. It sees the Eagles won the Super Bowl in 2025. Who won the Super Bowl in 2025? So the answer and the question are right on top of each other in the prompt. And that's how large language models are able to be aware of current events.
Okay. So you have to combine the large language model with some additional knowledge set. That's the retrieval bit of it, whether it's pulling it from the web, or I guess it could be pulling it from an internal enterprise document store or any number of places. And I guess for developers, it's important to keep the distinction between products like ChatGPT, which are already doing this, and just the foundational models like GPT-4o or many of the other models that are out there now. But I assume, building off your example, this applies to all models, right? No matter which foundation model you pick, you would have to apply this pattern on top of that.
Yeah, thousands of foundation models available today, and they all are like this, indeed.
Got it. All right. So I'm a developer. I've got my foundation model. I want to apply retrieval augmented generation. Obviously, I want to have some currency. I want to have relevancy in my answers, maybe to my business. What's the best place for me to go start? Do I need to go learn another product to go do search? Do I just plug into an API? Where do I go if I want to begin my RAG journey?
Well, there are a number of easy ways to do it that we have built into Azure today. So we do have Azure AI Search, and that makes for a very good backbone for any kind of a RAG system. In fact, we really retrofitted Azure AI Search in early 2023 to make it amenable to those types of use cases. One of the things that people often do when preparing their data for large language models is they enable something called vector search. And vector search is different than your standard old fashioned keyword search
Okay.
because it's much more robust in the presence of variants of language. Vector search is really a concept search. Whereas keyword search, for example, if I say, how do I activate the heated seats in my car? It would be looking in the manual, if I had connected it to my manual, for the words heated seats.
Okay.
But if I ask that in a different way, como activo los asientos calefactados, for example, in Spanish, well, then the words don't necessarily match if I have only indexed an English manual, but the concept matches because the concept of heated seats and asientos calefactados are exactly the same. Or if
Mm,
I say something other than that, like, how do I warm the chair, for example? Again, keyword search might not match, but a vector search might match. And so
got
a lot of what you need to do is enable that. And we have these tools in Azure that will do a lot of that stuff automatically for you.
Okay. So my next question naturally was going to be, all right, I want my data in a vector database to support this. Do I have to do that? But it sounds like tools can kind of help me along that journey if I at least have data to point them at. Is that right?
That's right. So more and more, we are automating that process of vectorizing your data, preparing it for vector search.
Okay. So there's some tools out there, things like Azure AI Search. Obviously, there's going to be a lot of considerations, I assume, as you get past the beginning of vectorizing your data, getting it to your large language model that a developer will need to unpack as they try to deploy RAG at scale. I don't think we can teach anyone anything in 10 minutes, but if you had to give people some ideas, some thoughts to bookmark and go read about later as they go down this path, what are some key things you think they should kind of take note of beyond the basics of vector and search and all of that?
Well, once you've got a basic prototype up and running, then you really need to think about evaluation. And we have evaluation tools also built into Azure AI. And there are lots of third party tools out there that you can use. But you can look at evaluation as kind of being the unit testing of AI. So for people who come from traditional development backgrounds, that unit testing, that evaluation is absolutely necessary. You got to throw at it thousands of examples of the kinds of things that people might ask, the kind of information that it will need to look up and evaluate how frequently it gets the right answer, and then mitigate where it might go wrong, usually by adding more or more targeted information to it. So, once you got that initial POC running, and you can do that very quickly. I mean, in Azure, for example, you can get that up and running lickety split, but you really need to think about testing and making sure that it works at scale.
All right. So when you start thinking about putting this to production, getting it to scale, you've got to make sure, just like code, you have some tests to make sure it's doing what you think it should be doing. And evaluations are the way we do that with AI, it sounds like.
That's right. And another major benefit of using an evaluation tool like this is you have to be aware that you're probably going to be changing out the underlying model fairly frequently. These models are coming out fast and furious. They get better almost every day. And that again points to the necessity of this evaluation tool and the data to support it. Because every time you change the model, you're going to want to rerun that evaluation. Just like every time you do a check-in, you want to rerun your unit tests to make sure you didn't break anything.
Okay.
Here, the same concept applies.
Okay. And you've just really touched on, I think, one of the things we kind of want to wrap up with today and get to. Things are changing so fast every day. Uh, how do I prepare for the future? You're an AI futurist. If I'm working with RAG, what do I need to be thinking about that's coming just around the corner that I should be preparing for now, so that I can make good decisions today, especially when it comes to RAG?
Yeah, well, one of the things to think about is that RAG up to this point has largely been applied to unstructured data like documents and PDFs and things like that. Now we're getting better and better at applying RAG to structured data also. And we
Okay.
at Microsoft, we've been working with our Fabric team, our sister team, to make it super easy to RAG to structured data. And that's the kind of thing that's going to be especially required as we move into this agent world. Like I said, where we're going here is that these agents are not just going to be looking up information to tell it to you or to answer your question, but to actually do something on your behalf. And they're going to need to be able to access both unstructured and structured data to do that job.
Okay. Okay. So really getting all the data in there, all the context, no matter where it is, what structure it's in. Very good to know. All right. So let's wrap it up here because we want to get on to the next bit of the segment here. But I think if you could leave our audience here today with anything, any pointer you think they should take, especially as they're considering RAG or going down this AI journey, what tip would you give to a developer who's new to this and just getting started?
All right. So, in terms of what tips would I give a developer who's just getting started with generative AI and with RAG? Well, the first thing I would say is come visit us in the Azure AI Foundry. That's ai.azure.com. And when you poke around in there, what you'll find is we have these playgrounds where you can actually set up RAG on the fly and try it yourself with your own documents or with web search and those kinds of things. And so there's a lot of tools available in there. And we also have a lot of relevant content on learn.microsoft.com, which points at our fairly extensive GitHub repos. In fact, Todd, your team just published some really good new GitHub repos with a bunch of sample code showing how to make this stuff happen. So I guess we have extensive resources here at Microsoft that can help you get started.
Well, that's perfect. So that we can go to GitHub, we can find some learning resources, we can go to ai.azure.com, get hands-on in a playground, start playing around. I really think that's usually the best way for a lot of developers to make these abstract ideas concrete. Go get hands-on, see it, try it, and I think that's a great pointer there. Well, Marco, I know our time has been brief, but we do have some other folks coming up after us. Farzad and Ayca are going to teach our audience here even more about working with RAG and how RAG works. So I guess thank you very much for joining us today, and thanks again for joining us on this first Ragtime.
Always good to talk to you, Todd. Thank you for having me.
That was an amazing interview. Now it's time to dive a little deeper into technical concepts. So, Farzad, tell me a little bit more about generative AI so we can dive after about RAG.
Sure, let's do it. So, in generative AI, in a one liner, it's all about content creation by API. So, in the world of generative AI, what you can see here on the slide are all the different possible things that you could do with generative AI. For example, write a tagline for an ice cream shop. I'm having trouble getting my Xbox to turn on, or writing code like SQL queries, or even image or video generation. Generative AI is super, super powerful, and the amount of use cases it unlocks for people around the world is absolutely incredible. And so that's essentially what generative AI is.
Perfect, exactly. Also, let's briefly talk about how an AI app looks like today. I always imagine an AI app to have a large language model, obviously, that can generate answers. But if I ask questions like, what is my company policy? What are my perks? The model may give me well structured, generic answer, but it may not reflect my company's specific internal policies. So, how do we help our developers achieve that?
Right. So that's a fair point. The problem is that generative AI doesn't really have context for your data, it doesn't know anything about it. And so how do you kind of achieve that? And so that's where retrieval comes in. And so think of if the LLM is a talented writer, retrieval is the part that supplies the right factual information. And so by pairing the two together, you can transform an AI assistant to kind of just a good guesser into a really accurate, context aware guide. And so, in short, here are kind of three strategies for how to incorporate domain knowledge into RAG, where you have prompt engineering, fine tuning, and then retrieval augmented generation. So that's where you really incorporate that domain knowledge from different large language models. And we're going to spend a lot of time focusing on RAG today.
Awesome. So now we set the stage a little bit, learned about generative AI and retrieval augmented generation. I want to dive a little deeper in real magic behind retrieval augmented generation. So I really amazed by the fact that RAG combines two different worlds like creativity of AI and precision of search. It feels like it's best of the two worlds together. So what do you think about that?
Exactly. So think of RAG like having a world class librarian that works side by side with a brilliant storyteller. And so the storyteller can then craft incredible narratives, but sometimes the storyteller can struggle to recall the specifics of certain facts or the right policy details, going back to our previous case. And so, meanwhile, the librarian or the retriever knows exactly where every piece of information is stored, and so it can fetch the references or citations on demand. And so when those two personas or people team up together, it really tells an incredible story. And so the storyteller's outputs aren't just imaginative, it's actually factual, concrete, and accurate, and all in all just grounded in factual real data.
This is super helpful actually for developers, especially working on scenarios like customer support, legal research. Instead of just generating classic answers, AI pulls specific real world information to back up its responses. So, is that the point?
That's exactly the point. So RAG makes AI not just smarter, but useful. And Azure AI Search plays a key role here. So with Azure AI Search, you can connect your large language model to your actual documents, your product catalogs, your FAQs, or any internal knowledge bases. And so this means your AI assistant doesn't just talk in broad strokes. It references your company's real jargon, your real resources. And so it's like giving your AI a backstage pass to your entire library.
Right. So let's break it down for our developers because Azure AI Search is our star. What does it take to set up retrieval piece in Azure AI Search and how does it work behind the scene?
Great question. So, as you can see on the slide here, Azure AI Search is a revolutionary RAG product available in Azure today. And so we have battle tested retrieval, a streamlined data pipeline, seamless developer integrations. And what good is all those amazing features if you don't have a strong enterprise ready foundation? And so, when you set up Azure AI Search, you start indexing your content. That's usually step one. And so imagine you have this huge, stack of documents, and so indexing is like creating a digital map of all the key terms, concepts, and structures that are inside of those documents. And so once that index is built, the search service can then quickly find the best matching pieces of data depending upon whatever task you're trying to solve or query you're trying to send. And so this is crucial because your AI model needs majority of the time a fast, reliable way to fetch the most relevant content.
Right.
And
So you
so,
mentioned
yeah.
something that I really like, which is indexing. That is step one, right? So without indexing, we cannot actually retrieve anything.
Yeah. So as you can see here, that indexing is step one. Is super, super important. And so when you feed data into Azure AI Search, it goes through a process where each item is analyzed or document is analyzed. And so what the service is doing, as you can see in this recording here, It extracts terms, tokenizes based upon different languages, depending upon whatever language you set that your data corpus may be in. And sometimes even you could optionally enrich it with extra metadata like named entity recognition, like tagging locations, captioning images, or identifying people's names. And so this result pretty much ends up in a structured, searchable index that you can query using natural language. And so think of it like building a sorted table of contents for all your data. And so once this table of contents is ready, you can send search queries to cut straight to the pages that you need.
Oh, got it. Okay. So it's not only storage, it's actually making your data smarter, which is super helpful. So now let's say we indexed our data and enriched our data set. Let's talk about vector search because it's one of the popular search experiences developers can build.
Right. That's exactly correct. And so before we actually talk about vector search itself, I think it's important to understand just vector embeddings at a very, very high level. And so think of vector search like giving our librarian analogy a really deep understanding of every single book in the library. And so if traditional search is like a librarian who can only match exact titles, if you like searching that HR policy, they'll only find documents with those exact words. But vector search uses what we call embeddings. And so think of these as the librarian's detailed notes that capture the essence of every single document. These notes are actually lists of numbers at the end of the day that help understand these semantically similar concepts, not just precise lexical or analysis or words. And so when you ask about workplace policies or HR policies, that librarian knows to go and check the HR manuals or maybe the employee handbook or guidelines because they understand that these are all related concepts to that query that you're trying to ask. And so they're not just memorized titles, they've truly understood the meaning about what each document is about.
This is awesome. So vector search works perfectly even if the words in our search, in our query, don't match exactly with the data we have, right?
That's exactly right. Azure AI Search is built to handle large scale scenarios. And so, under the hood, it uses efficient data structures and algorithms to quickly compare these vectors or numerical based representations of data. That find the most relevant matches. And so, whether you have, a couple, 100, millions, billions of documents, the service can scale to handle that level of performance. And so the analogy I like using is it's like having a supercharged librarian who can instantly pick the right books from an enormous library, no matter how big it gets. And so in this slide here, you can see the different types of vector embeddings, essentially what this really visually looks like to the naked eye, where you can use all these different vector embedding models to create that numeric representation of your content. And you can get really, really granular and fancy about all these different mechanisms of how to actually leverage vector embeddings and vector search and cosine similarity and all those fancy terms. But at an extremely high level, here's essentially how the vector search works, where you can compute the embedding vector for the query. You find what's called the k closest neighbors from your query vector to your document vector. And there's different ways, such as searching exhaustively or using approximations, which we'll get into in a later journey. But then here's a more real life example where you have a word like tortoise. You use a product or service like Azure OpenAI embedding model and create that query vector. And you get something like a very large array of numbers, and then you can search from your existing vectorized corpus. And so that's essentially how vector search works. So with that, Ayca, are you ready to see some code?
Yeah, let's see it in action.
All right, let's do it. So what I'm going to do here is I'm going to bring up a Jupyter notebook. And so inside of this Jupyter notebook, this RAG fundamentals, I'm using a few libraries here to actually conduct this demo. Azure AI Inference, OpenAI, and Azure Search Documents. And so real quick, I'm just going to set up my environment variables and library over here to authenticate into my Azure AI Search Service and my Azure OpenAI client. Your choice, use API keys or be extra secure and use managed identity. And so you can see here inside of this code block, I have a function here that says get embedding. And so this is going to be important because I want to create that numerical representation of data, right? And so what I'm going to do here in this prepare a question, you can see here, I have a user question. What is included in my Northwind Health Plan Plus that is not in standard? So you can see here, I simply just have this user question vector. And with this variable is then going to call this function. It's going to take this string of text as input and then create a query vector. Okay, so once I create that query vector, then I can do some really cool things with it, like vector search in Azure AI Search. So then I can use the search client in Azure AI Search to say, hey, I have a vectorizable text query. So I already did the due diligence of going through Azure AI Search and creating an index over a bunch of Contoso HR documents. And you can see here, I'm going to pass in the user question. I have a vectorizer in Azure AI Search, which we'll talk about as well in a later journey, my k nearest neighbors, which is 3, and the text vector field that has all the parsed text from my documents that I actually want to do the vector search over. So you can see here, if I print the documents, I have my chunk ID, my title, and my text. So this is giving me that contextual understanding or retrieved results in my RAG pattern. And so once I want to put that in action, it's RAG time. So what do I do here? I want to now use Azure OpenAI's GPT-4o model or whatever chat completion model you want to give a system message, something like you are an AI assistant, answer only facts listed in the retrieve context. Where's my context? I'm getting that from my search results up ahead. And then boom, I'm passing it into the chat completion model over here. And then hopefully you get a nice personalized response. The Northwind Health Plan Plus includes additional benefits such as preventive care, wellness programs, and so on. And so that is essentially how you do RAG in under 60 seconds via Python code. And once you do it in code, you can now see that you have a beautiful web app that you can actually leverage. And this is a real working sample where you can take the queries that you just did, package it all together, and actually show RAG in action, where you get the AI model response. And you can even deep dive and see the thought process from the model, the different citations, which is very important in a world of transparency, to make sure that your model isn't hallucinating and it's giving you the quality that you want to serve business value at the end of the day.
This is awesome. So let's put it all together. RAG gives AI the ability to retrieve and generate accurate answers. Search indexing transforms your data into powerful and rich format. And vector search finally ensures that the results are not just accurate, but they are meaningful. That's the next generation search experience we have.
That's right. And the best part is it's all accessible in Azure AI Search. So whether you're building chatbots, recommendation engines, search tools, or multi-turn agents, you have the power to experiment, customize, and scale as needed. And so imagining like having a personal research team working in the background, ready to provide high quality answers at a moment's notice.
Exactly, absolutely. I think to everyone watching, you should start small, have fun experimenting because with all of these tools, all of the capabilities that are out there, the possibilities, the apps you can build are endless. So enjoy experimenting and hopefully you build something in production in the future too.
Awesome. Thanks for joining us on this journey. And if you're interested in learning more about what we've discussed, you could visit this link at aka.ms/ragtime. And so this GitHub repo has a great place to start and learn more about RAG concepts.
Exactly. Now, to close out our very first journey in ragtime, I'll hand over to Nitya, who will summarize everything we just discussed in Doodles.
Let's recap what we learned about in RAG fundamentals. Chatbots are like storytellers, but they need the right data to provide relevant responses. RAG is like pairing up the storyteller with a librarian who gives them the right data just in time. Azure AI Search is that librarian. It can ingest your data, create indexes, and retrieve relevant results for your searches. Indexing is like a librarian who accepts messy data, then organizes it neatly into a searchable library catalog. Vector search is like having a well-read librarian who understands the essence of the data and can organize it with added context to make discovery easier. Azure AI Search is your supercharged librarian. It's built to handle large-scale data with efficient data structures and algorithms for indexing and search workloads. We just saw RAG in action, from the initial user query to delivery of the grounded response. So let's recap. RAG helps you retrieve relevant data to generate accurate responses for chatbots, recommendation engines, search tools, and more. Search indexing transforms the data into an enriched format for efficient querying. Vector search ensures that returned results are accurate and semantically meaningful. And Azure AI Search makes all this accessible in one service.